Okay, good afternoon class. Okay, welcome back after 1 week of independent learning week. Okay, so during the independent learning week, we will, you already cover for the continuous random variable, right? Okay, so for the continuous random variable, there are 3 important things, okay, that you need to know is a basis of integration. Okay, that one is a basis of integration. I provide already the slide and also the some exercises related to the basis of integration. Okay, but then we will do the tutorial this week. Okay, we will discuss the tutorial this week. Okay, I already upload the material for the continuous random variable. Okay, alright, so we discuss by this week during the tutorial. Okay, and then for the continuous random variable also you need to refer to the statistical Z table. Okay, so that one is the table that you don't need to memorize all the value in the statistical Z table, but then you need to understand how it will be used and how you're going to apply that table. Okay, alright, so let us continue with the new chapter, okay, which is the sampling distribution. Okay, previously you already studied for the technique of sampling. We have the probability sampling and then we have non-probability sampling. Okay, but then for today we will continue with the sampling distribution. Okay, so let us start with the population and sample. Okay, so the target of an investigation can be divided into the population and sample. Population consists of all subjects of interest to our research, and also the sample is a part of the population. It's the subset of the population. Okay, alright, so for this one, I think that the definition of the population and sample, you already get the clear definition. Okay, so we proceed with the population distribution. Okay, so for the population distribution is probability distribution of the population data. So when it is involving with the population data, all the elements are included in our data. Okay, so for the population distribution, okay, suppose that 5 students, okay, in advanced statistics class, and the midterm score of these 5 students are 70, 78, 80, 80, and also 95. Okay, so this one is the population data. Okay, from the population data we can determine the population distribution. Okay, so let X denotes as the score of a student. Okay, and then construct a frequency distribution table and probability distribution table from the population. So for this one, you will refer to the previous lecture. Okay, in week 1 or week 2 lecture. Okay, alright, so this one we have the X. Okay, X is the score of the student, 70, 78, 80, and also 95. Okay, so from the X here, you need to find the frequency. Okay, this one is an illustration for only 5 number of population. Okay, so the frequency is equal to 1, 2, 2, 1. Okay, so from the frequency, you can find the relative frequency. Okay, so the relative frequency is equal to frequency of each categorical divided by the total frequency. Okay, so you get this one. Okay, this is for the population. Okay, alright, so for the population distribution, okay, let us denote the score of a student, construct a frequency and so on. This one is the probability distribution table. Okay, so for the probability distribution table, we have the PX here, probability. Okay, so probability for X is equal to 70, the probability is 0.2. Okay, and then for the 78 is also 0.2, and for the 80, the probability is equal to 0.40, and then for the 95, it is equal to 0.2. How you refer this one? You can get from this one. Okay, alright, so the total of probability or the total summation of probability must be equal to 1. Okay, so you get all this. Okay, this one is for the population distribution. Okay, alright, so we need to developing a sampling distribution. What is the sampling distribution? What is the sampling distribution? Class. Okay, sampling distribution, we get the distribution based on the repeated sampling of the same population. Okay, the value of the sampling distribution we can get from the repeated sampling of the same population. Okay, so that will be developing a sampling distribution whereby this one is the summary measure. Like you find the center of tendency, you find the mu, and also you find the standard deviation. Okay, so the mu for the population, mu is always for the population, so you get 80.6. Okay, and then the sigma, okay, n divided by n, so you get 8.0895. Okay, this one is you already calculate for the central tendency in the first tutorial. Okay, whereby mu is always equal to population, x bar is always for the sample. Okay, since this one is referring to the population, so that one is a mu, and then this one also the sigma. Alright, so you get this one. Okay, alright, so for the sampling distribution of a sampling distribution of a population. Okay, so suppose we assign the letter A, B, C, D, E to the score of all the 5 students, so that student A, the marks A equal to 70, marks number B is equal to 78, okay, mark C is equal to 80, D 80, and also E 95. Okay, so from these 5 population, we want to create a sample. Okay, and then we consider 3 students are selected as a sample without replacement for a population. Okay, so from the population, you create a sample. Okay, you create a sample of 3 students. Okay, alright, so 5C3. What is the value of 5C3? The number of population is 5, and then you want to create a sample of 3. But then the sample is a without replacement. Okay, which means that A, B, C. It cannot be A, B. Okay, A, B, C, B, C, E, and so on. How many? The possible sample? 10, right? Okay, so you will get 10. Because of 5 population, the total number of population of student, okay, you only select 3 to be a sample. Okay, so the possible number of sample is equal to 10. Okay, but this one is a without replacement from the population, means that the possible sample is a B, C, okay, A, B, D, A, B, E. You cannot have the sample A, B. Cannot, because that one is a sampling with replacement. But in this case, they already restrict the sampling without replacement. So it can be A, B, C, A, B, D, A, B, E, okay, and then A, C, D, and so on. These students cannot be the same. Okay, so the total number of possible sample is equal to 10. Okay, so starting from the sample that you have, okay, you create that X is equal to sample A, B, C, okay, and the second column here is the score in the sample. Okay, for A, the score is 70, B is equal to 78, and then C is equal to 80. Alright, and the last column here, it will be X bar. Okay, X bar is the average of the sample. You cannot have the mu anymore because this one is a sample already. So ABC is the first sample, ABD is the second sample, until the last sample is the CDE. Okay, altogether we have 10 samples. Okay, so ABC 70, 78, and then 80. Alright, so the X bar is equal to 76. How to get the 76? 70 plus 78 plus 80 divided by 3. Okay, so the CDE is equal to 80, 80, and also 95. Okay, so you get the X bar is equal to 85, whereby 80 plus 80 plus 95, you divide by 3. So you get 85. Okay. Alright, so this is all the possible sample of their means where the sample size is equal to 3. Sample size is equal to 3. This is all the possible sample. Okay, without replacement. Okay, so the sampling distribution is the probability distribution of X bar is called the sampling distribution, whereby we repeat the same sampling okay, from the same population. Okay, all right, it lists the various value that X bar can assume and the probability of each value of X bar. Okay, in general, the probability distribution of a sample statistic, we call it as a sampling distribution. Okay, so they refer to the sample. All right, so this one, okay, the X bar is equal to 76. How they get this one? From this one. Okay, from the X bar, okay, they calculate the probability. Okay, we have 76, 76, 77, and so on. This one, you can see that the value of X bar is repeating here. Okay, and then you can replace in the X bar here. Make the probability distribution table. Okay, so 76, we have 2. Frequency is 2. 76.67, also we have 1. And the last one is a 84.33. We have 2 numbers of frequency. Okay, from the last row of this table. Okay, 84.33, we have 2. So you just write the frequency distribution table 2. Okay, and then the relative frequency is a number of frequency of each category divided by the total frequency. And the sum of the frequency relative is equal to 1. Okay, so this one. Any question from here? No, eh? Okay. Alright, so this one, the S bar is 76 and so on. Okay, you get the probability distribution function. Okay, so the P S bar is equal to 0.2 and the last one, you get the 0.1. Okay, based on this table. Okay, so you get this one. The total must be 1. Okay, in this case, if we have the total number of population is equal to 5, and then we select only 3 to be a sample. Okay, alright, so we get all this. Okay, alright, so this one is the mu S bar. Summary measure for the sampling distribution is equal to mu S bar. Okay, so the mu S bar, because this one is from the population also. Okay, the sample population. Alright, so you get this one, 76 plus 76 and so on, and then you divide by 10. Okay, why? Because we are referring to this table. This table. Okay, 76 plus 76 plus 81 and so on, you will get the mu S bar. Okay, alright, so for this one, we have the value, the mu S bar is equal to 80.6. Okay, so the mu S bar is equal also to the mu. Okay, from the previous slide. Okay, this one. Mu is also equal to 80.6, and then the mu S bar, the sample we repeat from the same population, also we get the 80.6. Okay, so they are same. So you can complete the theory, which is the mu S bar is equal to mu. Okay, because they will produce you the same final result. Okay, alright, okay, so this one you can use mu S bar is equal to mu. Alright, so we have the mean and the standard deviation. Okay, alright, so since the mu and the mu S bar is equal, but then you cannot say, assume that the standard deviation for this one is also similar. Okay, so for the standard deviation, since the mu S bar is equal to mu, we have 2 conditions for the standard deviation of S bar. Okay, standard deviation of S bar, we have 2 conditions. The first condition whereby summation or standard deviation of S bar is equal to sigma divided by square root of n if the number of sample divided by the number of population is less than or equal 0.05. Okay, this is the first condition. Alright, the second one, the standard deviation of S bar will be the sigma divided by square root of number of sample n. Okay, if the n over n is greater than 0.05. Okay, first thing you need to check the number of sample. Okay, and then number of population. This one will be n. Okay, n divided by n, either this one is greater than 0.05 or n over n is less than 0.05. Less than, sorry. Okay, there is. Okay, for the standard deviation of x bar. Okay, alright, so if n over n less than or equal 0.05, use the first formula. If the n over n, okay, is greater than 0.05, so you need to use the second formula. Okay, alright. Okay, we see the example for this one. For the sampling distribution example, okay, the mean wage per hour for all 5,000 employees, okay, who work at a large company is 27.50, and the standard deviation is 3.7. Okay, they provide you the number of population 5,000, and also work at large company, the mean wage for all. So this one is the mu. Okay, the mu is equal to 27.5, and the standard deviation is a 3.70. Okay, so in the next question is let x bar be the mean wage per hour for a random sample of certain employees selected from this company. Okay, find the mean and the standard deviation of x bar for a sample size 30, 75, and also 2,000. Okay, so let's do for the sample 30 first. Here, the mean wage per hour for all 5,000 employees. Okay, so for all means that the total number of population is equal to 5,000. The n is equal to 5,000. Okay, the n is equal to 5,000 who work at a large company. Okay, so the mean wage of all, right? So it is equal to 2750. Okay, 2750, but then this one is for the population. So they will give you the mu. Mu is equal to 2750. Okay, and then the standard deviation. The standard deviation is equal to 3.70. Okay, alright, so let x be the mean wage per hour for a random sample. X bar will be for a sample. Okay, X bar for a random sample selected from this company. Find the mean and the standard deviation. Okay, mean and the standard deviation for this one. Okay. So how to find the mean? How to find the mean for this one? If the sample size is equal to 30. If n equal to 30. So where to use this formula? They give you this one, right? So we have the theory u mu x bar is equal to mu. So this is the theory. So the mu for the x bar is also 2750. Okay, so you need to find the standard deviation for the X bar. Okay, so the standard deviation for the X bar, you need to check the restriction first. Okay, alright, so n equal to 30, the n is equal to 5,000. Okay, so n divided by n is equal to 30 divided by 5,000. So which one we use? The first formula or the second formula? This one will be what value? 3 divided by 500, 0.006, right? Okay, this one is a 0.006, okay, which is less than 0.05. So which one we use? The first or the second? The first. The first. Okay, you will use the first. So the sigma S bar will be the sigma divided by square root of n. Okay, so the sigma here is equal to 37 divided by 30. So you will get the answer. Okay, and then you will get the value of the standard deviation. Okay. Okay, all right. What if the number of sample is changed to the 2,000? Okay, so number of the sample of n equal to 2,000. Okay, so n divided by n is equal to 2,000 divided by 5,000, 2 over 5, right? So that one is a greater than 0.05. Okay, so if greater than 0.05, you need to use the second formula of standard deviation for the sample mean. Okay, so sigma x bar is equal to sigma divided by n. Okay, and then we have n minus n, n minus 1. Okay, so what is the sigma here? Sigma is equal to 7.30. Okay, 7.30 divided by square root of 2,000 multiplied by 5,000 divided by 2,000 divided by 4,999. Okay, so you will get the sigma for the x bar. Okay, mu for x bar is always equal to the mu, because we already proved from the equation and from the formula just now. Okay. Okay, this is the complete solution for this one, where n equal to 5,000 and then the mu is equal to 2750 and then the sigma is equal to 3.70. Okay. Okay, so this one is the properties of the sampling distribution. Okay, so for the properties of the sampling distribution, the dispersion of the sampling distribution is smaller, okay, is smaller than the spread of the corresponding, okay, population distribution. Okay, what is this mean? The sigma x bar is smaller than the sigma. Why? You can check from the formula. Okay, because the sigma x bar you need to divide by the total number of sample. Okay, alright, because the sigma of x bar is derived from here. Okay, sigma x bar is equal to sigma divided by n. So that is why the value of the standard deviation for the sample mean is always less than. Okay, alright, so we have the second properties of the sampling distribution is the standard deviation of the sampling distribution x bar decrease as the sample size increase. Okay, in our study we always expect that the value of the standard deviation will be lower. Okay, the value of the standard deviation lower, good. Okay, how to achieve this is you need to increase the sample. Okay, you need to increase the sample. increase the sample and the value of the standard deviation will be decreased. Okay. Alright, the standard deviation of the sample mean is called the standard error of the mean. Okay. So make sure that you increase the sample. Okay, they will decrease the standard deviation when you do the simulation. Okay. Alright, so this one is population is normally distributed. Most of our statistical tests or statistical method is depending and rely on the population that are from normally distributed. Okay, so when you have the sampling distribution X bar for X is equal to 5, okay, you see that the more dispersed of the distribution, whereby the standard deviation for this second figure here will be larger as compared to the last one. When you increase the sample size, okay, there will be less dispersed, which means that the value of the standard deviation will be smaller and the data point will be nearest to the center or the reference value or the mean. Okay, right. This is the properties of the normally distributed distribution. Okay. All right. So this one is the probability population that is not normally distributed. Okay, they are skewed to the left and also right. Okay, so when you increase, the n is equal to 4, the n is equal to 15, and then the n is equal to 30, until the last one is n is equal to 80. Okay, so you see that in D, figure D, they said to use sampling distribution of X bar, okay, whereby this one is equal to 30, so that one is approximately normal distribution. When they reach one of the sample size, which is 30, they can approximately that the distribution are normally distributed. Okay, but when the value is less than 30, so that one is considered as a population are not normally distributed. Okay, all right. So that one is 2. Okay, so some important announcement for the lab assessment online. Okay, so I will brief all of you regarding the online assessment. Okay, lab assessment are okay tomorrow during the practical. Okay, so tomorrow during the practical we will finish this one. Okay, and then we also I also will brief on the lab assessment. Okay, so no midterm, no written test and so on, but then you have the lab assessment. Okay, and then I will provide you 1 week, maybe 1 week time duration to complete your assessment. Okay, all right. So tomorrow during the practical we will highlight 3 things. Okay, we finish this one. During the practical we will finish this lecture. Okay, I will brief you on the lab assessment. Okay, and then the last one is you may ask for the case study if you have any issue with the case study. Okay, 3 things. And then the tutorial will continue with the continuous random variable starting tomorrow. Continuous random variable. I already upload all the materials from there. Okay, all right. So take your attendance and you may leave. Okay.